In this world of automated vehicles, we've heard about this technology for a long time. And for a long time, we've heard this technology is coming, and it still is not here yet in the way that people thought that it would be here. And for those of you who are unfamiliar with the different levels of automation, the most accepted levels is the SAE J3016 standard that has 6 levels of automation going from 0 to 5. 0 is no automation at all. Levels 1 and 2 are your assisted driver technologies, such as emergency braking, lane detection warning, et cetera, et cetera. And those are pretty much installed in all new vehicles that are being released on the market currently. Then you have level 3, which is quite a controversial level and a level that I'm not too fond of. It's where the vehicle should be able to drive in most circumstances, but you need to have a driver behind the wheel that if the vehicle beeps or signals its alarm at the driver has to take over control immediately and make a split-second decision on what to do. Obviously, if you're driving a vehicle and you're just sitting there not actually driving it and performing the navigation, you're not paying attention. So that is more a human issue than it is a computer issue, and it's a very controversial level that some manufacturers are deciding to skip altogether because there's really no way that's going to work. Then you have level 4 automation, where a vehicle should be able to operate within a given geofence area, and this is where our 2 manufacturers we'll hear from today currently lie. And then you have level 5 automation, which is this idea that you can pluck a vehicle at any point, plop it anywhere, and that vehicle will be able to navigate in that area. Waymo, which is currently the global leader in automated technologies, their CEO said that's pretty much a pipe dream, never going to happen. And if that's his vision and understanding of the technology, that we're never going to get to a point where you can plop an automated vehicle anywhere and have it operate without any sort of geofencing in the area, I think that's pretty indicative of how complex this technology is and how far we still have to go to have these vehicles operating on our roadways. So without further ado, and to go in any more, I will invite the 2 panelists up to the stage. Oh, there you are. Perfect. And we will get started with Aaron first. So Aaron is a solutions engineer with Navia. He has a diverse background, including automated vehicle operations and legislation, international business development, low-speed electric vehicle deployment, and small business management. Aaron joined Navia in 2017 and remains the longest-serving employee in North America. At Navia, Aaron works to educate potential customers on the benefits of first-mile, last-mile mobility, connected vehicle technologies, and automated vehicles. So Aaron. Button there.
Thank you for the introduction, Christy. Thank you all to Josipa Q-Trick as well for really bringing together all the different low-speed electric shuttle manufacturers, Easy Mile to get there, also partners within the program. I'd also like to thank Sarah Yeager. She's my counterpart at Navia, who's really been the main driver of this relationship with Q-Trick. So thank you to Sarah as well. So just a little bit of information about Navia, who we are. We are a French company headquartered in Paris. I work for the North American subsidiary based out of Saline, Michigan. It's in the neighborhood of Ann Arbor, Detroit region. Great place to get automotive talent, engineering, and manufacturing skilled labor as well. We've got 2 plants, one in Lyon, France, one in Saline, Michigan, where I'm headquartered. And we're currently at around 300 employees worldwide. So Navia, we really are a true vertically integrated OEM. We've done everything from developing the platform of the vehicle, developing the sensor integration, the algorithms, and the automated driving system. We handle the manufacturing, and we handle the back-end system that does all of the monitoring, software updating. So we truly have control over the entire process of the vehicle. We've got over 130 vehicles currently sold worldwide, and we're operating in 26 different countries. We'll go a little bit deeper into that later. And then we do have some strategic agreements with key industry partners. Valeo, they're a large sensor provider to the industry, very well known. Keolis, large transit operator, and it's important that we develop these relationships with the transit operators. Just because Navia is not really looking to come into a city, come into really any site and create a transportation network. We want to work with the local experts to know how we can best use where, when, and how these vehicles. So the vehicle, Navia, we actually have 3 that we're producing right now, but just for the focus of the first and last mile, which is really, I think, the way that these vehicles are going to have the biggest impact in the near term. We're going to be talking about the Autonom Shuttle. It is 100% battery electric. We can carry 15 passengers, 11 seated and 4 standing. We're operating right now at about 25 kilometers an hour maximum speed, so we are limited to certain sites. Very dense urban areas and campus environments are really the best areas for these vehicles right now. We're generally operating about 9 hours runtime off of that battery charge. And one of the beautiful things about this vehicle is that it was designed to operate free of any infrastructure improvements. We're not even requiring painted lane markings. We're not requiring any magnets embedded in the roadways because we want to be able to use these vehicles now without requiring massive capital investments to really recreate the roadways that they're going to be operating on. And it is important to note that we can operate within dedicated lanes, but we are also operating in the regular flow of traffic and have been since 2014 when we started operations in Switzerland. So just at a high level of how our system works, every company has a little bit of a different way to find their position, to look for obstacles, and to make the decisions. We think that it's very important to have redundancies built into these vehicles. So for our localization, we're relying off of satellites to find our position. And we have a local GNSS reference station, which is going to give us about a 2 to 3 centimeter degree of accuracy. It's extremely repeatable. And this is important because without the requirement for lane lines that cameras are looking for or embedded roadway sensors, we're going to be able to stay centered in the correct lane. We're going to be able to stop at an intersection, whether or not the stop sign's there. It could be obscured, covered up with snow, knocked over by a vehicle, but we're going to stop there every single time to maintain the highest level of safety. We also have a LiDAR system that's both used as a redundancy for the localization, so it can triangulate our position within the environment should the GNSS fall out for any reason, but it's also used to detect obstacles. So we're looking at a base reference LiDAR map that we create ourselves, and that's compared to real time. So any differences between those two maps is going to be detected as a potential obstacle. We're going to be tracking, predicting trajectories, and then anticipating those obstacles getting in our way to always give right-of-way priority. We're not really getting into the sort of ethical considerations of classifying obstacles and deciding if anything gets in our way, we're just going to stop in place right now. We do also have some other redundant systems, odometry sensors, inertial measuring units, just in case everything goes out. But ultimately, the redundancy that we like to rely on the most is the human operator. We keep them on board, both because we're legally required to in many environments, but also just because, frankly, the public is not ready for a vehicle to be operating truly without a driver. We've seen over 50% of the public really apprehensive about hopping in a highly automated vehicle. So one of the ways that we've overcome that is by doing pilots, trials, demonstrations, and being that the vehicles within our niche are low speed and they are operating on a fixed route, it is a very palatable way for the public to operate and get their first experience in an automated vehicle. We actually showed through surveying that was conducted by AAA in Las Vegas that we had about a 30% increase in public confidence of automated vehicles for someone that had never ridden in a vehicle versus after they had ridden in the novice shuttle. We are also able to do V2X interactions, so most commonly that would be through DSRC communicating with things like traffic lights, because again, we don't want to rely on cameras, which can become dirty, and traffic lights can become obscured as well. So this really is a first last mile solution. We are looking to increase the density of the transportation network, and the way that we're able to do that is going back to working with the local operators. We find the gaps within their system, whether this is a first and last mile gap, whether this is an expansion of service that may not justify a full-size bus, or somebody that's looking to retrofit sort of legacy infrastructure. We are looking at a couple of different projects in the United States where we're going to be retrofitting elevated railways and turning these into roadways that automated vehicles can essentially use. And they're able to retrofit these rather than spending hundreds of millions, sometimes billions of dollars. So coming back to the use cases, cities, campuses, hospitals, airports, anywhere that people are taking trips about 5 kilometers or less is going to be a great use for this type of vehicle, being that it is low speed. You're not going to want to spend a half an hour on this type of vehicle. It's really all about creating those connections to make sure that the public transportation system is as usable and flexible as possible. Because when we have a flexible and usable transportation system, then we replace some of those single occupant vehicle trips. And those vehicles can stay whether in their remote parking lots or whether they're staying in the parking garage. They're not going to be clogging up the roadways. We're not going to have distracted drivers looking for their next parking space. So it's going to be a much more efficient and safe system when you have these first and last mile transportation solutions. So just a quick use case. This was one of our first launches that we had here in Switzerland. We've moved over 20,000 passengers, and it's about a 2.5-mile route. So this is one of our longer routes that we're deploying, and it's been highly utilized. It's using 2 shuttles now, and they actually have about 4 different routes to choose from, depending on special events and different demand response. We have it on pedestrian sites. So this site I really like to highlight is La Défense. That's a financial district just outside of Paris where we've got a massive number of employees operating within this public square going from building to building. There's also some interesting architecture, so tourists are walking around. It's a large public square. There's no other vehicles operating, but the French government, after doing a lot of diligent research, got enough confidence to say you're okay to operate there. There's no bollards, there's no lane lines that keep people from walking in front of the vehicle, and it operates with a very high level of service. People appreciate the fact that they can use an air-conditioned vehicle to get across this massive site. Another case that we have currently running is at the University of Michigan. This is on their North Campus Research Center. This is a little bit less trafficked area of campus where the University of Michigan Transportation Research Institute is, also the M-City Automated Vehicle Test Track. So we're actually doing a real-world use case up there where we're picking up students and faculty from remote parking lots and then bringing them to different buildings throughout the campus. That is currently running, and there is no expiration date on that. So we are looking at scaling that up and replicating it at different areas of the campus. Downtown Las Vegas, that was probably our most visible deployment that we did here in North America. That was a partnership with AAA and also with Zappos and the city of Las Vegas, where we were picking up people from the Fremont Entertainment District and then connecting them to different areas of the city that tourists generally don't go to. So we were able to drive revenue into those areas, and we were actually able, I went on a trip with some friends out there when the shuttle was running. It was about a 45-minute wait just to ride on the shuttle. So it really does drive extra attention into whatever neighborhood that you're putting these vehicles in. And then this is just a quick global footprint. I like saying that we operate in 26 different countries, not only because it's just a flashy figure, but since these are intelligent systems that are really just based on collecting data to improve themselves, the data that we're going to be collecting in Vegas versus Australia versus Hong Kong, versus Helsinki, they're all going to be different types of weather environments, different pedestrian behaviors, different driving habits. So we're really getting a very, very rich data set for having, as I like to say, only 130 vehicles out on the road. So that being said, just a little bit of talks about the future as I wrap up here. We are working towards being compliant with Americans with Disabilities Act. We'll work towards meeting that in Canada as well. I understand it's a very, very close system because we really do want to provide equitable mobility for all. So providing mobility for those that are disabled, elderly, or economically challenged is very important to Navia. We are working towards level 4 autonomy because a lot of our customers are very eager to remove the operator from the vehicles. And when we're legally allowed to and when the public is ready for it, we want to be ready for that as well. And then finally, there was some news recently that Navia is also providing our software to third-party companies. So we have the Autonom Tract. You see, that's a airport ground support equipment vehicle. It was already a legacy platform. It's an electrified luggage cart, and we're putting our automated driving system on that. We're going to be starting trials with that later this year. So look for Navia in the future, not only to produce shuttles, cabs, but we're also going to be providing the software to third parties. So with that, I'm a little bit over, so I apologize, but I thank you for your time.
Thank you, Aaron. I'd now like to welcome up Joseph. Joseph's the Director of Sales for Easy Mile in North America. Joseph has worked within transportation since 2005 in numerous customer-facing and business development roles. Joseph worked for First Group PLC prior to joining Easy Mile and experienced working across both bus and rail contracts, both in the UK and in the US. Joseph currently lives in Denver, Colorado, where Easy Mile's North American headquarters is located. Joseph.
Good morning. I'd like to obviously echo what Aaron was saying. Thank you very much for having us here. It's great to get everybody together and be able to talk about these very exciting things. I think with Easy Mile, there's definitely a lot of similarities between obviously what you've just heard with Navia. but a lot of differences, and hopefully I can just touch upon the differences as opposed to just replicating a lot of the stuff this morning. So we've been around also for a while, 2014. You say a while, but I guess in this industry that is a long time. We have approximately about 200 employees to date, and we are headquartered as well, like Navia, in France, but we're in the south of France. It's warmer in Toulouse. So that's where we're based for the corporate headquarters, where a lot of the R&D kind of takes place. Denver, like Kristen said, as you probably can tell, I'm a local to Denver, Colorado, but we also have offices in Berlin, Singapore, and Adelaide. We are a privately held company. Navia, like Aaron didn't say, but are a publicly listed firm, accountable to obviously their shareholders. We are accountable, but accountable to our strategic stakeholders. We have Alstom, the high-speed tram builder. Continental, probably best known for their tires, but you open up the hood of any vehicle, you probably see quite a lot of Conti parts in there. And finally, BPI France, which is a national bank of France, specializing in startups and long-term companies like ours. We do like to say that we're the most deployed shuttle worldwide. I'm sure we could probably get into a debate on that later, but that's what we like to say. We've got about 100 and, sorry, the slides are slightly gone off here, but got about 120 shuttles deployed worldwide, and again, about 27, does that say? 27 countries. So that's something there. We've come into Canada. We've got a great relationship with PWT. I'm sure you've heard about the Ella shuttle that's on our platform, and on the East Coast in Montreal with Transdev. Because we, again, like Navia, like to work with different operators, with the city themselves. We don't want to limit ourselves to one vendor, so we are agnostic across that. And again, like the Navia shuttle, it's so important that we have accessibility for all, so we're pretty proud of our built-in wheelchair ramp. So kind of very similar profile, 15 passengers again. We've got a couple more battery packs. We claim 16 hours worth of autonomy. But with the air conditioning, with heating being used, you're absolutely right, the battery life can get affected, so we would say about 8 hours if we're using those on full. Again, no need for additional infrastructure. It is a level 4 shuttle that is running on that predetermined, pre-downloaded map. And we like to operate in environments, apologies, these are in miles an hour, but on 30-mile-an-hour streets. And for us, the shuttle we will have running at about 15 miles an hour maximum speed in operation. And I'm sure we'll probably get into that later on throughout this morning's session. But we believe that really is on the upper limit of what we like on deployments of these shuttles. When you have people standing within a vehicle, the way it's been designed is to have people seated and standing. Bringing the speed beyond that is something that we're not necessarily as a business and probably as an industry as well comfortable with, just because they're not secured with seatbelts. So again, we can probably go on to that later, but I just wanted to just quickly add that. So the topic of this fireside chat was, where have we come from and where are we going? So believe it or not, there are 3 different iterations of the EZ-10 shuttle. Slight, but there are differences for sure. So the first shuttle we rolled off in 2014, that is the Gen 1, Gen 0 technically. That was our project in California at Bishop Ranch. There's a private business park there. So that was our first deployment in the US. In the middle, you guys probably better know it as Ella, but that is our EZ-10 Gen 2 shuttle. So a lot of similarities, but improved battery packs. Essentially, each iteration, as we move across, is responding to customer and client demands, essentially. So the Gen 1 on the left-hand side didn't have heating, so we went to Minnesota and we went to the colder parts in Canada. There was definitely some question marks on the vehicle there, so we introduced a heating system on the Gen 2. And then finally today, on that right-hand side, that's our new baby. That's the Gen 3 shuttle. Really imaginative names over at Easy Miles, I'm sure you can appreciate. Again, it's an updated sensor stack, really being ensured to demand that we can not only respond to situations faster, like intersections, being able to read the environment quicker. It's actually got latest industrial grade type sensors. So again, we can dig into that a little bit later. Two very different use cases we've realized as a business that the autonomous shuttle can answer. On the right-hand side, absolutely like Aaron was saying, it's that first and last mile connectivity, right? With the operator on board, facilitating customer demands, being able to involve itself in pedestrian-controlled environments, tourist centers. We like to be able to think the shuttle brings people to transportation options. So it really feeds and adds into the system. On the left-hand side, that's kind of where we're really starting to pick up a lot of focus and get a lot of interest from the industry, because this now is the no-op, what we call, removing the operator and having the vehicle run in a fully autonomous way. Essentially, as the vehicle was designed, it hasn't got a steering wheel, it hasn't got brake pedals, it has not been designed to be driven or really have anybody on board. So that's kind of a big focus for us now, and in segregated type environments, and in secure enough situations. We have one use case, which I can talk about a little bit later, but that's really where the business is focused, because that's really the only way a real client can get any return on investment as we start looking at investing into the shuttle and kind of the long-term future. So the difference with EasyMile, just to quickly touch upon this, is we are a software company. We do not manufacture, we do not have a manufacturing plant. We partner with the leading manufacturers in the world. So the Easy-10 is built by Ligier. Back in the day, they were a Formula One racing team. Definitely the speed element has not translated over from the Formula One days, but the dedicated production line, the kind of focus on low scale, low volume shuttles, that's been the great partnership with Ligier. Alstom for the tram, obviously with our partnership there. We also do have a product with baggage tractors. We realize there's a huge need for automation, not necessarily on the airport side, but definitely within warehouses and with construction when, for example, take a car manufacturing plant where they're just moving engine parts from one side of a warehouse to another. That's been a great use case for us. The robo-taxis, it's a confidential project at the moment with two OEMs. Avico, that's our partnership with a larger scale bus, working with US and North American and Canadian manufacturers. So hopefully we'll be in a position to announce something pretty soon on the 100-passenger bus, which gets really exciting when you start looking at return on investments. And then other industries up there. This is a video which I'm not entirely sure will play. It should. Yeah. It should play. But we have our project with TLD. And again, the title of this chat was, Where Are We Going with Automation? I think this is a great example. So I'll hopefully try and let that play.
Introducing the Tracked Easy, a groundbreaking driverless and zero-emission electric tow truck. Revolutionizes operational flexibility for ground transportation of goods on industrial sites, logistics centers, and airports. Follows predefined routes, warehouse management system orders, or on-demand requests via an app. Pulls up to 25 tons without dedicated infrastructure. Suitable for all weather conditions, indoors and outdoors. Detects and avoids potential obstacles thanks to a full set of sensors. LiDARs, radars, stereo cameras, GPS, odometry, and inertial measurement unit. Wide angle of vision, sees up to 100 meters at the front and 40 meters to the sides. V2X communication. Works with EasyMile Fleet Management, Easy Fleet navigational software for mission management and route optimization. Tracked Easy, the ideal autonomous solution for industrial sites, logistics centers, and airports.
Oh, we don't want to watch it again. Okay. Oh, back? Okay, perfect. The reason why I wanted to just show that was just because that's the capability of the software and the capability of autonomous platforms. The sensor stack that you saw on that shuttle was actually on the sensor stack on the Gen 3 and the latest iterations of vehicles. So I just thought it was just interesting because the concept, like Aaron was saying, is exactly the same. So we've got that Tracked Easy shuttle deployed on a airport in the US. Unfortunately, they want to remain anonymous, but it is there, trust me. Just to quickly finish off, the industrial sites like I was talking about, that was the operation where we're running no-op. It's essentially connecting the cafeteria area to the main plant, the main warehouse. It's about a 700-meter loop, and it's just fully autonomous, being managed remotely. In Sweden, this is a brand new residential area for that first and last mile connectivity. Babcock Ranch is a planned community where we're utilizing on-demand, so riders are able to request a shuttle from an app. And then lastly, there's Charité in Germany. It's one of the largest hospitals actually in Europe, and we're operating there within the parking lot. So that's just a selection of some of the interesting projects, all slightly different, but I'm sure we probably really want to get into the questions, so thank you very much for your time.
Okay, so I'm sure we're going to have a lot of questions from the audience shortly. I have a lot of questions, I always do. So I want to touch on one point before getting into some of the initial questions that we discussed. Sort of on a point that you've mentioned that I've heard quite a bit, and Aaron, please feel free to comment as well, this idea that the shuttles travel slower because the passengers aren't seated down, and that it would stop abruptly, and then that wouldn't be comfortable for passengers. But then the argument should hold then that if we were to then take that technology and put it on a bus, the same concept would apply, because there are people standing in buses. So when you're working with Iveco, did I pronounce that correctly? Does this same condition hold where their max is 15 miles per hour because of that parameter that passengers aren't seated? And if I understand correctly, and correct me if I'm wrong here, the reason that it has to travel so slow is because the technology now isn't at a point where it can come to a slow stop, it comes to a rather abrupt stop, and so it's a limitation of the technology rather than a general limitation of having people standing.
I'm sure there was pretty a few questions in there, but let me firstly tackle the first one on the speed of the shuttle. And Aaron, feel free to jump in. If we're talking about a 30, 40-foot bus, this is a horrible conversation to have, but in an accident with a 30, 40-foot bus, the weights, and I'm not an engineer, so this is where I'm looking to Aaron to really help me out here on. But the closing speed and the impact would be fundamentally different from a 30, 40-foot bus hitting an Easy 10 shuttle made out of composite materials, aluminium. So, yeah, I think there's a fundamental difference there, which I think we just as a business don't necessarily see the technology advancing anymore. I don't know if you wanted to touch upon that.
Sure, yeah. So, I mean, just the nature of the weight and size of these vehicles means that they're also going to stop much quicker. So if you imagine if you're driving just a normal sedan and you slam on the brakes, your stopping distance and the force that you feel on your body is going to be much greater than on a 40-foot bus, which is just going to take much more time and have the feeling of a much slower deceleration. So that's part of the reason for the limitation on speed, and also part of the limitation for the limitation of speed is just frankly the processing power and memory, because we are dealing with massive files that are these 3D LiDAR maps that are both being used for reference and generated in real time. We're just limited to essentially how much information can we process at a safe level. So when I started with Navia about 2 years ago, a little bit more, we were limited to about 10 miles an hour. So we've increased that speed about 50% since then. And I would imagine that we're going to keep increasing. I think mechanically we're limited to about 50 kilometers an hour. So we're still never going to be on the highway with these kind of vehicles. But as processing and memory becomes quicker and cheaper, we'll imagine that would accelerate the pace of the vehicles as well.
And Joseph, you raised a good point too to carry on here. Obviously, neither of your vehicles were ever designed to live up to motor vehicle safety standards. They're not going to be crash-worthy. They're designed, I often refer to them as glass boxes. They're not built like your traditional automobile is or your traditional bus is. So do you foresee a future where your vehicles, just based on the physical design of the shuttle, will be able to travel at those speeds, understanding that if it did get in an accident, of course the passengers are going to be a lot more vulnerable to injury or, God forbid, death?
So I think from EasyMar's perspective, we're definitely looking at autonomous solutions for different use cases. And I think the Easy-10 will always, I'm not going to speak on behalf of Navia, but that type of shuttle, that 15-passenger shuttle, will only be facilitating the use cases for those lower speed type connectivities, that first and last mile. You're absolutely right, though, when we start looking at the bigger buses, when we start looking at alternate solutions, you're right, the speed is definitely going to be a limiting factor. But take an airport, for an example. You know, the airport environment, the shuttle, the vehicles, the big buses, they're not going much beyond the speed of what the Easy-10 is doing today. So from our perspective, it's just finding that right use case. And I think for a business, we've got the private sites and we've got the public sites. And I think those two different use cases, like I was saying, one has the focus on the no-op, that kind of focus on returning investment, whereas the public sites has a different focus altogether on advancing the technology. So it's those two pieces.
And with regard to the safety standards, at least as far as Navi is concerned, it's really not a factor of them not being crash-worthy. The Navi vehicle has a full steel underframe. We've got a full roll cage, so it is a very well-protected vehicle from the occupant standpoint. Really more the reasons that both of our vehicles aren't compliant with federal motor vehicle safety standards is really just because of their novel design. We don't have a designated restrained position for a driver. And then from that reference point, you have so many different standards. You need gauges, you need mirrors. So just that fact, you know, we would have to just completely redesign our vehicle to become compliant with those safety standards. And then also just to get back to the just sort of the overall energy of impact of vehicles that are our weight and speed. Navi, we did some calculations because we're looking at potentially trying to fit this into a low-speed vehicle category for homologation purposes. And with the speeds that we're currently traveling at our maximum weight, we actually only have 50% of the energy. We're at about 40,000 joules of energy for an impact at our weight and speed versus a 25-mile-an-hour golf cart. So it is actually quite still safe in the speeds that we're operating at from a crash-worthy standpoint.
Excellent. Did you have another comment?
Yeah. Well, I was just going to absolutely agree to you on that point. But yeah, saying the vehicles aren't safe or necessarily aren't crash-worthy, I definitely would challenge. So thank you for adding that. Hopefully, within the next couple of weeks, we can announce a project with a Canadian institution where we will be looking to crash test the vehicle. Because I think there's a saying, which I won't say now, but you essentially have just got to do it. Or stop talking about it and essentially just do it. So we know that the Local Motors Ollie, I'm sure we probably all saw that video. It definitely made very uncomfortable watching, especially considering the amount of glass that went absolutely everywhere. I think both the Navia shuttle and the Easy-10 are built and designed fundamentally different to the Local Motors Ollie. So we would definitely welcome the results of this crash test.
Perfect. I look forward to that for sure. Do we have any questions from the audience? Oh, yes, we do.
Hi, I'm Rosemary Fram, a journalist. I went to a talk a year and a half ago by the head of Keolis, or one of the high-ups at Keolis, about they're doing that pilot in Lyon, which you may be familiar with. And he was sort of emphasizing the fact this is also about monetizing, but showing people, moving towards making people have to pay to use the roads and infrastructure associated with that. Is that what you're working towards, or in what capacity you're working with Keolis? Yes, either, or you can both answer if you can.
So with regard to congestion pricing and things like that, I think it's definitely going to increase the speed at which we'll...
Congestion pricing, but everything used to pay to make people pay more to just use the road, period, not just congestion.
Okay. So from that standpoint, Navia really doesn't have a position, to be honest with you. We really just want to follow the lead of the local operators. So if we're going with a system where we're using, pricing to sort of drive people's behaviors, then we'll follow the leader in that standpoint. But I don't think we're really going to take a position to prescribe one solution over another.
Yeah, I would echo that.
Doug?
So there's been speculation, I guess, that if you operated these vehicles in an open street, pedestrian dense environment, that I guess the pedestrians would discover if they could require these vehicles to stop easily just by walking in front of them, and that would effectively make them impossible to operate in such an environment. So I think a lot of that has been speculation, but I noticed you had some, like on that La Défense open plaza type environment, basically whether there's been any emerging practical experience with that.
So specifically with regard to the La Defense site, we did not notice that people were sort of bullying the autonomous vehicle, so to speak. They weren't purposely walking in front. More often we just saw people on their cell phones who were distracted, just simply, walking in front of the shuttle. So at that site, it was a rather short track, and it was really more of a convenience. So people really didn't complain about a lack of service, but in terms of so Navia did a open roads pilot with the University of Wisconsin-Madison, where we were operating in one of the most dense parts of the campus for a week. And the first day we did see a couple people, kind of jump in front of the vehicle. But after they kind of realized that, okay, it's going to stop, it's just another vehicle on the road, it became yesterday's news to all those people. So very quickly that type of behavior went away.
Yeah, I would just add, probably on every single deployment, one of the first things that people do is, will it stop? And walk out in front of it. But like Aaron was saying, people get bored of that pretty quickly when the vehicle does stop every single time. So yeah, they just eventually stop. But it does happen for sure, but they get pretty bored.
Michael?
So I have a question about public sector regulation. What's your experience in Canada been with public sector regulation on road and off road?
From our perspective, we had that public road deployment in Montreal. I will say that at the federal level, it's very accepting. It's very open to these pilots, to these implementations. It's more at the provincial level. We've seen complete disparity between the different provinces. There's one, I can't unfortunately mention at this stage, we were running into a lot of issues. And it's really, really slowing us down. But Montreal was just a great stakeholder alignment. It was great to kind of just have everybody involved, and we didn't see any hold-up. I will say that in the US with NHTSA, the application for public road demonstrations takes about 45 to 60 days. In Canada, our experience has been 45 to 60 minutes. And that's no joke. Our applications, when they went in, they were accepted almost immediately that same day. So it's just amazing. The openness, in our experience at the federal level, it's just the provincial level where we've had issues.
So I would definitely like to echo that. At the federal level, Transport Canada has been a great partner, more of a collaborator than an agency that we have to seek the approval of and really bow to. So to that, Navia actually received Transport Canada's first 5-year waiver for the operation that we have in Candiac. Generally, this is a 1-year waiver, which has to be perpetually renewed, but we have enough experience, and I'm sure Easy Mile is receiving 5-year waivers now too, that they're confident enough to give us an extended waiver, and it's a complete night and day from what we do see with the NHTSA in the States. It's very much trying to slow down the process, and it really does. I mean, 60 days is even quick for some of our applications, honestly, in the States.
Bryce?
Okay. Hey guys. So let's pretend that we've just solved the problem of keeping these things charged like 24 hours a day. We can get into that later. But so some of the people we're working with are dealing with the idea of autonomous goods delivery. Not the first mile. The tugs, the sort of electric vehicles in the industrial sector, but kind of a grocery pizza. 3 a.m. You want a pizza, you order it up, and a robot shows up at your house. Where do you see the convergence being? Because you've got one end where the goods are moving around the warehouse. You've got the other end where you can take the people to things. In the middle, there's this idea that we can take goods, even say from the warehouse over to Starbucks at 3 in the morning when they're stocking up for the day. How do you see all of that fitting together in the systems you're designing?
I think that's a good level 4 to level 5 type debate, really, isn't it? I think, like we were saying at the start, Bryce, it really is essentially the right use case. And yeah, it's funny when you're looking at moving parts in an industrial warehouse or moving passengers around an airport, and then you raise a point moving pizza around. Yeah, it really is just the different use cases. But there's nothing that stops the technology from doing something like that, and that's why it's so important to look at no-op and have that operator removed, because then the possibilities really are endless to what autonomy can do.
Yeah, I would agree. I mean, you're seeing companies all the way from Neuro making small delivery devices all the way up to companies like Domino's using Ford Fusions to deliver pizzas. And I think both of our vehicles can really be used for more than just the movement of people. We can have these vehicles really be utilized 24 hours a day, delivering people during the peak times, delivering goods during the off-peak times. And it's all about using the right tool for the right job. So really making sure that these vehicles are highly utilized and yeah, used for the movement of goods and people.
But that point you make, Bryce, and definitely like Aaron's saying there at the end, does just come down to people, clients, customers, cities, looking to have autonomous pilots. And for us at Easy Mile, and I'm sure Navia as well now, we're done with the demos for demos' sake. If anything, actually, it detracts from what the technology can do today, having the vehicle operating in a parking lot or doing like a 3 feet back and forth loop. I think the question then will get asked, like we were saying at the start, is, are these vehicles ready today? And I think those type of environments make people potentially think they're not. But then when you actually look at the track record of companies like ours and what we've been able to achieve over the course of 4 or 5 years, really does show that what's happening in the next 5 years. And maybe you might get your pizza delivered to you right now, Bryce.
Excellent. Okay, I have 3 final questions. We have about 3.5 minutes, so hopefully we can get through those 3 in the last 3 minutes. So the first one, to go back sort of to the theme of the panel, where we've come from. Both of your companies have been around for about 5 years. So in terms of the autonomous technology, what would you say has been the biggest advancement? Sort of if you can pinpoint 1 or 2 things, the biggest 2 advancements the technology has seen over the last 5 years in your companies.
People walking out in front of the vehicle. No, I'm joking. For us, Easy Mile, it's been the lack of industrialization and the lack of components built for the automotive sector. I think we're still working with components that are really built more for the robotics center. And when we're looking in cold climates, when we're looking at even hot climates as well, it definitely does add a challenge to the advancement of the technology. But our partner Continental being one of them, they're focused on industrial grade radar, which will really help us amongst other components. So components in our short amount of time, I'd say, is one of the big things for us.
Yeah, and I would say just finding a set of components that's going to work in all the different type of environments, because a lot of these do have limitations with the cold weather, especially since we're both battery electric. Operating below freezing temperatures tend to get pretty difficult unless you can keep that electrolyte liquid. So I'd say just really finding a single ring to rule them all as far as a technology package goes has been the biggest struggle.
Okay, and you may have just answered my next question as well, but I was going to ask, what do you foresee as the biggest challenge to overcome in the next 5 years to really bring your vehicles to that level 4 stance where you are comfortable as a company removing the human operator from the vehicle?
So we've already done that. We've already removed the human operator from the vehicle. So it's more building on those use cases, realizing when someone gets into the shuttle, how will they make it go? So it's that whole use case, and it's that whole example which we've all probably heard 1,000 times with the elevators, with having the operator on and then removing them. So we want it to be as intuitive as getting into an elevator and just choosing your floor, and I guess that's what's going to be happening for the next 5 years.
Yeah, I'd say the biggest limitation to get to that level 4 of all of our vehicles working without an operator, it's not the technology. We're there today. Easy Miles testing, Navia is going to be starting testing within an industrial site later this year. And we've proven in different scenarios with internal testing that we can do that today. The biggest limitation in my mind is going to be just the public's adoption and perception of being able to get on and like you say, just press a button just like you're getting onto an elevator.
Mm-hmm. Okay, excellent. And then Joseph, you kind of raised this point a little bit ago, just saying that pilot projects now aren't necessarily helping you in all circumstances. So can you speak to that a little bit? Because this is a message that we put out at QTRIC a lot, that 2-week pilot projects aren't going to advance the technology. So from your perspectives as manufacturers, what kinds of pilot projects might help you? What duration do you need? What kind of circumstances do you need? What kind of data collection do you need? What kind of partners do you need? Who has to be at the table, and what are the circumstances where those would actually benefit you? And what are the circumstances where that's benefiting the city and potentially public acceptance, but not actually the technology?
So you have 30 seconds.
Well, I'd say the sweet spot that we've found is anywhere from 90 days to a year is a good sweet spot. Anything less than 90 days, it's really just PR. It's really just getting people experiences on the vehicle, but finding out all the different situations that we can get in, all the edge cases and all of the challenges that we may need to overcome when we come back for a commercial deployment. Generally, we can learn these lessons in less than a year, but we're not getting enough of these lessons learned in less than 90 days.
For us, yeah, it's a big thing is resource allocation. These shorter term demonstrations really depends on what vehicles, if any, we have available at the time. So that's been a big challenge for us because we can't foresee these 90-day projects. I'd say the other thing really is just, for us, we want to be actually solving a transportation issue with the EZ10 being the solution, as opposed to just doing another PR event, just doing another ribbon cutting event. It just leaves a very bad taste, I think, in the mouth of the taxpayers who are essentially paying for this in cities, whereas we could actually be solving a real use case today with, in my opinion, the state of the technology, which is ready for the right use case.
Amen. That's definitely what we've been preaching, and I'm sorry that our third colleague from To Get There couldn't join us today, but To Get There has had a very firm stance in this, and I feel in a lot of ways To Get There is not as known in North America, largely because they firmly will not do pilot projects. As you were saying, in terms of resources, for them, they think it's way more money than it's ever worth. It doesn't help them. There's a ton of resources that go into it, especially when it's new jurisdictions, new regulations, as you were saying. I know the provinces in Canada, as you mentioned, very, very different. Federally, it's okay, but the provinces form a big barrier. So for them, it's not worth the pilot project stage, and we definitely agree with that in terms of the fact that public dollars go into pretty much every one of these pilot projects, and that's not a good use of public dollars if it's only for PR and a little bit of public acceptance, but not actually something that's tangibly going to progress the technology. So with that, I'd like to give a round of applause to our two panelists here. Thank you.